Hello everyone. Welcome to the next lecture on capacitor and its capacitance in module 4 of electrostatics. So these brief outline of the presentations or the points to be discussed. At the end of this unit, learners are able to derive the concept of capacitor, effective value in series and parallel combination, compute the capacitance of a composite dielectric, and derive the formula for energy stored in a capacitor. So how you define the capacitor? Okay, or how the capacitor is manufactured? Two conducting surfaces separated by an insulating media is called dielectric or capacitor is called which is called as dielectric or capacitor. What is a capacitor? It is the two conducting surfaces separated by the insulating or dielectric material. So its shape may be rectangular, shape may be circular, spherical, cylindrical. It is also known as condenser. So what is capacitance? Capacitance is the property of capacitor to store the electrical energy in form of static charge. So it is a property of this capacitor to store the energy in form of static charge is known as the capacitance. The capacitance is defined as the amount of charge required to create a unit potential difference between the plate. It is what amount of charge which is to be accumulated on this capacitor plate to create the potential difference between this plate. So let us understand the working of capacitor with DC supply. So here one DC supply is taken and it is applied across the capacitor through one switch and galvanometer. Switch and galvanometer is connected in series. Initially the switch is open. When I turn on this switch, okay, so when this switch is turned on, the excess electrons from the electrons from this conducting plate, due to this application of this positive plate, the electrons from this conducting plate, that is a negative charge, is get attracted towards the positive terminal of the battery. As soon as one electrons escape from this conducting plates, number of electrons are less than number of protons, that is protons are less, the protons are greater than electrons, hence this plate will become the positively charged, and this electrons drift from the battery towards the other plate of the capacitor. Hence number of electrons at this Y plate are starts adding, means number of electrons at this Y plates are greater than the number of protons, hence it becomes the negatively charged. This process will continue till the charge acquired by this or the potential difference across this is equal to the battery potential. When this both potential becomes equal, then no current, no charge will flow, or no charge will be flow, hence the capacitor is fully charged with the voltage V. Okay, so these are the content, how this electrical charge, when electrical potential difference becomes equal to the battery EMF, electrical potential difference between x, y and y becomes equal to the battery EMF, flow of electrons are ceases. Under such condition, if the battery is disconnected, so if this battery is disconnected, then also the capacitor remains charged for a long time. It stores the electrical charge as a potential of charge on the plates. The charge on the plates is proportional to the voltage applied. So what is the charge on the proportional is equal to voltage across it. So this Q is proportional to V. Q is proportional to what? V. So let us see what is the relationship between charge and the capacitor. The charge on the capacitor is proportional to the applied voltage. The charge on the capacitor is proportional to applied voltage. Let V is the applied voltage across the capacitor, then charge on the capacitor is proportional to each other, as Q is proportional to V. So to remove these proportionality constants, so Q is equal to C, where C represents the capacitance of the capacitor. So C is equal to what? Q upon V farad. So let us see the definition of capacitance. The capacitance can be defined as the ratio of charge required to attain the potential difference between the plate. It is what? It is defined as the ratio of charge acquired to the potential attained between the plate, that is Q upon V. So I will define the 1 farad of capacitance. 1 farad of capacitance as the capacitance of the capacitor which requires charge of 1 coulomb to create the potential difference of 1 volt between the plates. So in this, if the when you say this capacitance is of 1 farad, when the charge of 1 coulomb is required to create the potential difference between these plates are of 1 volt. So hence it is known as 1 farad of charge. Okay, so see the relationship, we see the relationship between charge and the capacitor. Consider this, these are the parallel plate capacitor. This conducting plate is having the area in meter square, and the distance between these two plates where the dielectric material is filled, it is in d meter. The distance between these two plates is what? D meter. So how you calculate the electrical flux or charge? Electrical flux or charge is equal to q, and flux density, the flux density, that area is a meter square, hence flux density is equal to charge q upon a coulomb meter squares. It is electrical flux density. And how you calculate the intensity? Intensity is equal to v upon d. As we see, the intensity is equal to what? Voltage upon d, and it is mentioned in terms of Newton per coulomb. But the flux density is equal to, we know that the d and e is having relationship, that d is equal to epsilon into e, that is d is equal to epsilon 0 epsilon r into e. So where is e? E is equal to v upon d. So d is equal to q by a, substituting d is equal to q by a, and e is equal to v by d. So e is equal to v by d. I bring this v term towards this side and a term towards this side. So q by v is equal to epsilon a divided by d, epsilon a divided by t. But we know that q by v is equal to capacitance c, hence c is equal to what? Epsilon a upon d. Epsilon is nothing but epsilon 0 into epsilon r. So epsilon 0 epsilon r a divided by d farad is the value of capacitance. So this is what parallel plate capacitor do. If you want to calculate the parallel plate capacitor, it is epsilon a upon d. So if you remember the formula of resistance, in the resistance, how you calculate the resistance? R is equal to rho L by A. Whereas in this, and you calculate the inductance. To calculate the inductance, we take 1 L upon mu 0 mu R into A, where in that case area, in both the case area is at denominator, but in capacitors area is at numerator and distance between the plate is at denominator. So epsilon 0 epsilon R A upon D is the value of capacitance. So what is the dielectric strength, or what is the dielectric strength? Electrical field intensity is given upon V upon D. If we start increasing the voltage, keeping the distance between the plate is constant, we are keeping the distance is constant, and if you increase the voltage, means if we increase the voltage keeping the distance is constant, E is also starts increasing with same rate. If distance between the plate, if D is decreases, then also the electrical field intensity starts increasing. This field intensity represents the force acting in the dielectric medium. As E increases, center of positive charge is pushed towards the direction of E, and the center of negative charge is opposite in the direction of P. Every electrical field is having its own capacity to withstand with E. So if this E is exceed beyond the withstand capacity, the force on the molecule will become so large, the electrons break away the molecule and causing the ionization and free charge. The charge recombine and they vanishes the capacitor plates. So here if we see, these are the negatively charged, these are the positively charged. If the force is sufficiently developed between this plate, if E is beyond the capacity of this dielectric media, what will start? These electrons break this dielectric media and it starts the recombination. Is positive and negative charge will recombine and they become neutralized. Hence capacitor will don't have any charge, so no more charge will be stored and it's said to be punctured, or it's said to be breakdown. So how will define the dielectric strength? It is the ability of insulating material to resist the breakdown when voltage is increased across it. When we start the voltage increasing across it, it resists to the the ability to resist the breakdown by this insulating material is known as what? Dielectric strength. The breakdown strength of insulating material is expressed. How will it express the breakdown strength? Voltage is in volts, distance between the plates is in meter, so it is mentioned in terms of voltage per meter. Generally this voltage is very high, so it is mentioned in kV per centimeter or kV per mm. The breakdown strength of air is 30 kilovolt per centimeter. What do you mean by 30 kilovolt per centimeter? If I place the two electrode in a air, if we place the two electrode in air at a 1 centimeter distance, and if we if we start increasing in the potential at 30 kilovolt potential, we will observe that the air between these two plates is get ionized. Hence, at the 1 centimeter away, if we maintain the 30 kilovolt, air between that is get breakdown. So what is the breakdown voltage? Breakdown voltage is the voltage where the dielectric media of the capacitor breakdown, that is, it is called as breakdown of voltage. Breakdown of strength, how this breakdown of strength is affected? Breakdown of strength is affected by temperature, type of material, size, thickness and shape of the plates, presence of the air pockets in the material, moisture content of the material and molecule arrangement of the material. So what is the dielectric loss? Dielectric loss, leakage and loss. If there is no leakage of the current in the dielectric medium and insulation is perfect, then the charge on the capacitor plates hold for an hours. Okay, so if this capacitor is pure, what is the pure capacitor? That is insulating material between the plates. If it is suppose a very pure, that is it's having the infinite resistance, then the capacitor will not discharge at all. But in the world, no insulating material is so perfect, it is having its own resistance. Hence the capaciting property starts discharging through this body resistance, that is small leakage of amount of current always starts flowing, and this capacitor will discharge automatically after few minutes or after few hours depending upon the rating. This resistance, obviously it is an insulating material resistance which is very high. Okay, if the resistance is very high, then dielectric leakage and losses will be low. That is, what is the losses? Losses is equal to I square R, and R, if this resistance is very high, the current is very become low, hence the dielectric loss in the material will be low. Okay, so thank you. In next lecture we'll see the capacitors in series and capacitors in parallel. Thank you.